And one of these days, I will start one of these webinars correctly. Welcome, everybody, to another webinar from Lidaholics. In a few minutes, I will go ahead and introduce the team from XGrids who have graciously decided to stay awake until 1 a.m. their time and come and tell us about their cool products. I'm a huge fan of their products, and almost everybody I show it to is a huge fan. They've really brought about SLAM scanning to a new era, so to speak, as far as able to combine Gaussian splats and LiDAR. But I don't want to take away from their glory. I just want to take a few minutes to go over a few housekeeping and upcoming events that we're going to do. Just in case you're ever interested in meeting up with us anywhere, we will be at Geo Week, February 10th through 12th. We will be here locally at the LSAW, February 26th through 28th. That's here in Washington. And then we'll be at the NALS in Nevada, March 29th through April 1st. So if you're interested in any of the products you see on any of our webinars, especially this one, feel free to approach us, talk to us at any of these events or at lidaholics.com. We reach out to us there, check out the website. We can help you get your hands on some of this cool tech. All right, so what I'm going to bring on right now is Mindy and Max from XGrids. Mindy is their marketing guru, and Max is the guy that you call when you can't figure something out. So, Mindy and Max, thank you for joining us.
Hi. Hello, everyone.
Hi, Mac. Thanks for having us.
Hi.
Perfect, and it is all yours.
Hi. So first, a very brief introduction, and here our XGrids teams, a very young team but very energetic. And here Mindy comes from the overseas marketing team, and also Max comes from our technical support. And thank you very much for Mac for holding this event. And it's a very good opportunity and our honor to be here and give you a quite deep introduction of the XGrids technology and the products. So the first part of so today's topics will divide it into several parts. First part, I will give a brief introduction of the whole technology things and the company backgrounds and how our product portfolio and the solutions conclude or try to solve the problems and issues around 3D worlds. And Max will tell more about how our product works in the workflows, and he will also answer technical questions about or your concerned issues. So first, let me present my screen for the slide sharing. So if you got any questions or comments about these presentations or the topics today, you can just comment on the webinars links. Yeah, first let me share the screen. So hi everyone, can you show my screen? Can you see my screen here? If you can, just type 1. Yeah.
We sure can't see it.
Yeah, okay. So actually, XGrids is a very young and energetic team here, and we are not only a hardware provider, because for most of the people, they know XGrids for our scanners, especially the LiDAR scanning systems. But we not only manufacture of the hardware, but also the solution and the 3D intelligence technology provider. And so the core technology of the company is 3D reconstruction. And other than that, we provide reality capture solutions as well as spatial intelligence and photorealistic metaverse solutions. And here is a very brief introduction of the backgrounds of the team. Even though the team founded in 2020, very young, relatively young, but the backgrounds and the team itself has long experience in 3D reconstruction. And the founder and CEO, Dr. Zhao Kaiyong, also the first product manager of the DJI Terra. So we are very familiar with the photogrammetry methods of the 3D reconstruction. And the core member of the team comes from the DJI and very big companies of the Chinese manufacturers and intelligent technology provider. And then we bring about the first generation of the like-so scanning system in 2022. And it's becoming the bestseller of the same type of the scanner in China and also in the Asian area around our country. And then we continue to bring about more and more compatible and very convenient mobile scanning systems for not only the professional one. We also bring about more compact and suitable ones for consumer grade or entry level grade. So this is our product and technology portfolio. The problem or issues we want to solve is that we want to build a bridge between the physical world and the digital world, because we find there is a great opportunities or gap between the 3D worlds, because we have more and more growing needs upon the 3D worlds, but the production cost is relatively high. So that we try to bring about the softwares, hardwares for for bridging this gap. So firstly, we got tools for data scanning or data collection. The hardware can do the mobile scanning first. And then we got data processing software for different kinds of data processing. Firstly, we got point clouds processing software, and then we bring about like so CyberColor, as far as many people know that it's a 3D Gaussian splatting software solutions. And then not only stopped in this stage, the data capture and data processing stage, we also strive for the application parts by developing lots of SDKs for different kinds of 3D rendering tools like the WebGL, Unreal Engine, Unity, as well as the Season. So that's why our partners or developers, they can use that plugins in their traditional development workflow to integrate the result of the 3D data. And then the result or the deliverables we give in this stage is the not only the point clouds itself, but also the mesh models and the 3D Gaussian splitting result. The reason why we want to bring this is that we think that 3D data is not only for the accuracy, but also we find a new opportunity to balance the gap between the accuracy and the visualization, because more and more people want to use that 3D data in a more visualized way. So that point cloud as surveying purposes data format is widely accepted by most of the surveying industry people, but more and more people in other industry who need 3D data, they need more visualized way to see and use the data. And so that's why we not only provide the reliable and compatible scanner itself, we also try to make the solution can cover different kinds of workflows in the whole 3D industries. So the software and solution itself is not only automated, but also try to reach them or push the boundaries of the accuracy, the real-time accuracy and the visualization effect. And here is some highlights of the scanner or the mobile scanning system itself. First, it's quite user-friendly. There is a joke or a very short story to make it easier. We want to this scanner not only used by some professional surveyors, even though the girls or women can use that scanner very easily. So we designed its user experience quite easy to understand. So it only cost us like 5 minutes to get started. And then it also can reach the high precision of the LiDAR features itself, because the LiDAR is quite widely accepted by the surveying purposes. We start from the surveying purposes, and we try to make that tools can be used by more and more people. So, but come back to our starting point. High precision is the basic requirements of the scanner itself, and then it's I think its biggest features of the scanner itself, it's real time, and we call it the first real time scanners in the world because we think that real time is the real feature of the SLAM itself, because when it can do the mapping simultaneously, by this we can call the scanner a SLAM scanner. So without real-time calculation or the processing, we don't think it's a real SLAM scanner. So the real time is the best thing we benefit from the scanner, and so that you can see the data or the 3D reconstruction result even on site, to check whether you missed or capture all the kind of the things you want in the situation or your required scenarios. Then we also have other modules for the remote transmission and other professional software and accessories for different kinds of scenario scanning. And then here is our flagship. That flagship much more for the professional surveying purposes. Its working range from 120 meters to 300 meters. It's a quite traditional surveying one, and you can also get a relative accuracy up to 1 centimeter and absolute accuracy 3 centimeter. So you can choose different kinds of type of the LiDAR for the different efficiency requirements, and so its scan rate you can choose from different type. So this professional one, we can use that for topographic survey, even though that area cannot for joint survey. And you can also use that for mining, because we will share several cases that we apply this data, these scanners in some very complicated scenarios. And we also use that for AEC surveying, architecture, engineering, and construction. And also we use that for production plan. And so it's quite a traditional professional surveying scanners. And it's we just launched it last September before the interview, and it also received a lot of leads and interest from the customers and partners all around the world. For the best thing it can bring about is that it generates real-time data comparable to those post-processed by other scanners or software. So you can see the result here. You can get very dense point clouds in real time, which means that you get the deliverables for other workflows right after you finish the scan. For some of the cases, you can use that for CAD joints or beam model joints directly. And then you can also get a real-time absolute accuracy up to 3 centimeter, and you can guard coordinates in real time. And its point spacing is less than 1 millimeter. So that for some very beautiful elevations or facade, you can see the details in a very vivid way. And so all these kind of things make that scanners robust and reliable for some very complicated cases like the tunnels and very big parking lots. And then other than the professional ones, we also got like, so Kitty and Kitty K1 is becoming the bestseller I've known in this field, as I know. And this one is very lightweight, only 1 kilogram, and its working range 40 meters, as some of the people know that's a LiDAR for designed for. And it's a relative accuracy up to 1.2 centimeters. So it's very suitable for most of the indoor cases, mobile scannings. And we also use that for 3D Gaussian splatting and make that scanners and the solutions become widely accepted by most of the people who have very little knowledge about the surveying industries. They can also use that mobile scanners for the photorealistic 3D model generation. And so here, the result you see is not a picture or video. That's the 3D Gaussian splatting results we generated by, we scanned by the Lexo K1 and captured and processed by our software. And And here is the supporting software. First, we got point cloud processing software, which compared with like so scanners for professional data processing, but it's really easy for entry-level surveyors to use that because you can use the one-click project processing for all the point clouds processing. And you can also use some very user-friendly segmenting or measurements tools and the stockpile measurements here in the software. And later on, I will give several cases we've done. And the most thing I want to introduce or emphasize is the the word SLAM-based 3D Gaussian splatting solution, because we are also excited about all the feedbacks and effects of this release since last April. As the one time we released that, we received a lot of popular feedbacks. So they can see the result is quite photorealistic, very vivid for the 3D reconstructions. And most of them just ask, what's the difference between this 3D Gaussian solution compared with others? So we must say that the SLAM itself or the LiDAR itself really help the solutions for more complex the scanning, for big and complex space scanning, and very dark and feature space area scanning. And we also get this kind of Gaussians quite different from others, only get very small objects, or they must capture the data, the reality for some rounding, for different rounds of scanning. But we just use that scanner walking around, and you can get a result in a very easy way. And you can, or based on the point clouds itself or the calculation of the 3D models, you can also do centimeter level accuracy measurement. Other than all these kind of things, other than the visual effects, we can also use the result for further developments, different kinds of portals and developments. So as you see, we can also use that joystick to do the control and use that for viewing on the cell phones, laptop, web, or VR headsets. And we think that's the most exciting thing is that you can use the photorealistic model in a very immersive and interactive way, quite different from the traditional panoramic view or some photos just stitching together. So that's a totally game changer things. And here is a very brief workflow of the whole thing. First, we use the mobile scanning system to do the reality capture. If you do a road plan in the scene, and you can use that scanners for different rounds of scanning to gather data. And second, you use your laptop for the local processing. All the things is automatic, so you just drag the folders, the scan data into the software, and you just weigh the all the data. You don't need to do the collaborations or and very complicated training or use some very expensive online service. And then when you gather data, you can have three different kinds of ways to use that. Firstly, you can use the local viewer to see the data, and you can navigate in the whole 3D model things in a free way. So different from the other Gaussian splats, you just see one point and you see that from different kinds of perspective. But in our viewer, you just navigate in the first perspective, which is just like you were here. You were here even though you never been there. And then you can also publish the result into as a web link so that you can share the result with your customers and friends. And they can also use the avatar. You can also use the avatar in this viewer, in this web viewer. And then for those who have the development experience or Unreal Engine, Unity, or WebGL, they can use the LCC plugins we launched on our developer platform for the further or secondary developments. So for some of our partners also use that plugins for the applications in various industries. And later on, I will also introduce several cases that our partners use that. So for all these solutions, we got two key competence. First is that 3D visualization. So for different kinds of results like point clouds, mesh models, and 3D Gaussian splats, take this park, this 25,000 meter square park as an example. If people use the traditional way to do that, people may take it may take 1 to 3 days to do the capture itself. People may do the photo or use the measure type or use the CAD drawings to do the reality capture things. And it will take another 10 days or more to do the office work in the 3D software like the 3D Max, Blender, or something like that. So for the things down, they may take like half a month. But for Lexo systems, it only takes us like 20 minutes to scan the whole parks, and the processing part only takes like 300 minutes in the laptop. And then you got 1 minute to publish the results like this into our server so that you can share that with the customers and friends. Another competence is spatial measurement. So to be balanced between the visualization and accuracies, we also want this solution solve the basic surveying problems and issues. So take this factory as an example. If you use the traditional stationary scanners to do the data collections, it may take like 8 hours to scan the whole floor, but we only use 8 minutes to do the scan. And use our software, you can output RCP format into the Autodesk system for the further CAD drawings or beam model drawings. And for us, not only the surveying industry, but also AEC, digital twins, natural resources, and culture and tourism, or the industry that needs 3D data for the visualization and accuracy, they can use these solutions for different kinds of scenarios, problem solving. So first is very normal one. We use that for the as-built measurements. In this case, the buildings just close to each other. They are just very close to each other. So people cannot use the drones or the taking photos ways to do the capturing because they will get some errors. But we use that scanners for the mobile scanning and use the point clouds for the CAD drawings. And the result can be used as a land archive, or the building renewal, and the as-built documentations. Here we also use that for the beam model drawings. And the data itself can also be imported into other software for the segmenting and the distinguishing of the key features. So the data itself can be used for digital upgrade, security plan, as well as for autopilot or the automobile systems planning. And here we also use that Gaussian splats for the scan to beam workflows improvements. As you see here is a very vivid examples of the Gaussian splats. On the left hand is the real site scanning. It's not panoramic video. That's the Gaussian splats result of the whole site. And then people can also overlay the beam models together with the on-site models so that they can compare the different results of the different stages to see whether there's some modification need be done. And you can also import the Gaussian splats or the point clouds into the Revit for the reversion projects. As you see here in the Revit, if you draw the beam model based on the point clouds we imported into the Revit, here you can also jive viewer here and see the results simultaneously. So that make the 3D designers and the beam model builders see the results simultaneously to put they can just modify their results in a very quick and direct way. So this kind of things can not only used for beam model building, but also the management process of the whole construction procedures. People also use that for design collaboration if they want to add some other annotations and notes based on the 3D spatial informations. They can also share that with the colleagues, they are not on site in a very remote place, they can also see the data in a very vivid way. And here is also very typical ways of applying the LiDAR in mobile system, mobile scanning system. It's the stockpile measurements. So for the area and volume calculation, we can do that for real-time calculation right after you finish the scan, and use that data for the processing, and you can get reports for the areas and volume automatically. So all the kinds of things can be applied in mining, food inventory, irregular piles measurements, and construction material inventory measurements. And we also have some case in landscape resources statistic documentations. So in this area, the drone just not permitted to get into, but we can use the mobile scanners for landscape scanning. So if you use that LP360, you can also use that for the automatic extractions for all the elements, especially for the vegetation and some edge of the roads or the buildings. And we also use that for the assets documentation and urban plan. So this case happened in China, and we mount that on a car for less than 20 kilometer per hour speed, so that you can get a whole point clouds models for the roads, very long roads. And here is another exciting case with in mining tunnels. So we use that DJI L2 for the on-air aerial data capture, and use the Lexo scanning system in the tunnel scans. And we combine these two data together. We use the Lexo studio software to do the map fusion automatically, so that you can get whole models of the mining systems, so that they can use that data for the management and the production safety plan. And we also do some very big projects for the world's longest undersea road tunnels like this. And other than that, we also use the software for the forensic purposes. So use that for the this evidence reservation, compared with the traditional way, as not only get photos or panoramic view or the point clouds could as you know, point clouds, it's quite hard to load that for some of the computers. So we just put that into 3D Gaussian splitting, and the professionals can use that data for the evidence analysis. And it was also used in anti-terrorism security plans. And the site reconstructions can also put some emphasis on the cultural reservation things. And here is another case we've done with the scanning systems. And in this case, we scanned 8,000 meter square factories. And we got point clouds in real time. But if you want to get mesh, you will use that for the Lexo Studio processing. And the 3D model builder can use that. You use the mesh models and panoramic overlay for the further development and 3D modeling. So in this case, we just rebuild every element of the factory, and in the systems we overlay the data of the robotics simultaneously. So the manager of the factory can see the real-time status of the robots in the systems. That's because the reality we captured is vivid as less than 1 centimeter accuracy, so that the data can be combined in a very accurate way. And we also use that for the solution of the power stations. In such a large case, some of the parts cannot be captured by drone clearly. We use that handheld scanners on the floor and to walk through and get a result like this. Here is the Lexo Studio viewer, so that you can see the 3D Gaussian splats in the first perspective. And here we also put some examples of the real estate, put that online to do the presentation. And you can also use the clipping box to get the floor plan in a very quick way. So you don't need to draw the 3D drawings again. And users can see the whole structures of the villa in very conveniently. And the result can also import it into Unity for some more interactive 3D application development. So in this case, our partners in Japan, they just put that result into the Unity for the interactive 3D. And you cannot only use that or view that on your cell phone or laptop. You can also use the joystick to do the control, which is really more immersive for the cultural preservation projects. And here is the recent result we've done with the Pico and Quest 3 VR headsets. As you see, when we scan different kinds of scenarios around the world, and you can put that into the VR headset, and for some short time rendering, and you can use that stick for the free navigation. Here is the site I scanned in Chicago this last winter, but I can still like feel like I can get back to that university. It's a very large case. I scanned it like 25 minutes, and then we can also use that in some Apple Vision Pro. We'll get a more clear result. And other than that, for the surveying and AEC industry, as well as the cultural preservation things, we also try to apply the 3D Gaussian splatting and the SLAM solutions into the virtual production industries. And later on this month, I will also hold several webinars about this filming and video shooting areas. So in this case, we use that Gaussian splats result for the VFX, the special After Effects. And then you can also put that onto the screen, LED screens for the coordination of the people, the real people, and the live videos, so that you can use that also for the scouting things. If you want to set a stage or the scenarios for the video shooting, you can use that 3D Gaussian splats for the planning, because you not only see that result, you can also measure that in centimeter level accuracy, so that if you want to do some decoration towards according to the plan or according to the production requirements, you can also use the software or the Gaussian data for reference, and the directors and the producers can also discuss that based on the reference. And that's all the things I want to share today. So XGrids try to carry out more applicable and convenient solutions for 3D industries, which is not only for the accurate purposes, but also you can use that in a more visualized and interactive way. So we also welcome partners and developers from all around the world to join us, use these technologies for more and more 3D applications. And then let me introduce Max for the further workflow explanation. Max? Hi, Max. Mhm.
Okay, here I am now. Yeah. First of all, thanks for a complete overview of our products and their applications. I know it could be a lot of things to digest for our audience. So I guess what I'll do right now is I'll try to provide a kind of like a summary of our products, and I guess I'll point you guys to some useful resources that you can turn to if you want to, like, say, download our software and play around with it. Because I feel like the best way of learning how to use it is by actually doing it yourself. So what I'll do over here is I will share my screen and basically point you towards our official websites, which you can download the software and also its user menu, and then follow along with the recorded tutorials and play along and learn it with your own pace. Let me share my screen now. So here, if you just go to our official website, which you can just type like XGrids into Google, it will lead you to this page. And so here, basically, you can find all the introductions to our products. But what I want to point you towards is this support page. So in this page, you will be able to find all our products listed on the left side. And for each product, you have like 3 tabs over here. You can find the download link, where you can also download the software manual and also other useful information, such as like other like setting tutorials and how to get activation codes, etc. You can also find this tutorial tab, which will include the detailed software tutorials, which are also separated into episodes. So you can follow along. And you also have this FAQ page, which will guide you through some commonly asked questions that range from how to operate this device to like how to use this function, what does it mean by a specific function in the software, all the way to say, how do I solve the problems, or what do I do if I see this error code. So it's a very comprehensive guide to how to use the software. So I guess to start off with some kind of summary, or basically restate what Mindy has said about our product lineup. So here, as you can see, we have 2 handheld scanner series. On the left side is the L series. It's more like a survey grade series. It focuses on collecting high quality LiDAR data, because it has a slightly better LiDAR head, which collects more points per second and also collects from a longer range. So this is our L series. Right next to it, it's our K series. So this K series, it's equipped with a different type of LiDAR head. It covers a shorter range and collects fewer points per second, but it's way more portable. It only weighs about 1 kilogram. So yeah, from these 2 devices, the data collected from them can be used for both Lixo Studio, which is showing over here. It's a software that focuses on getting high quality point cloud data, and also it can be used for Lixo Cybercolor, which is showing over here, which are more focused on generating 3D Gaussian splatting data. So over here, one thing I would like to mention as well is this Lixo Go app. So this app is showing over here. It's how you control the device when you're actually actively scanning. So after you connect your phone with the device, you have to open up Lixo Go and control your device with this phone app. I will show you some pre-recorded video that will kind of lead you through the workflow of from collecting data all the way to processing data. So you can find it from our official YouTube page. To access our official YouTube page, you can either just like go to YouTube and type in XGrids, or you can like from this website, just scroll all the way down. And yeah, you will be able to see this. And clicking it will lead you to our official YouTube page. So here in this YouTube channel, in the playlist, we have put together some very informative videos that covers from like how to operate the device to how to perform specific functions within our software. So I think what I'll go through for now is we'll walk you through some videos about data collection. So it will cover some data collection tips for you to follow along so that you get the best quality data during the collection. So I have already downloaded the 2 video from this playlist. It's this scanning guideline for Lexel series, episode 1 and 2. So I guess what I'll do over here is I'll just play this video and comment throughout so that you guys can have some idea about how to operate the device once you get a chance to play around with it or to experience it with hands-on. So
Max,
to start
I'm
off,
sorry, I don't mean to interrupt. I believe you're still just sharing the book a demo page.
oh, okay. Yeah, thanks for pointing that out. I have to yeah, let me share entire screen. Is it coming up? There you go. Okay, so as you start scanning, the first thing you want to do is connect the scanner to your cell phone using the app I just mentioned. So after you've connected it to your cell phone, you want to place this device to a flat surface. It could be on the ground or on the table, but just make sure it's standing still on that flat surface, and then you would like to do the initialization process, which is what this video is all about. So this is a screenshot from the Lexel Go app. So once you connected your cell phone to your device, you'll be able to see your device information from here. So this is your device. It tells you device version, serial number, and device status. So online means that it's connected to your phone. It also tells you the device battery percentage, and also how much storage is left in that SD card. So to start scanning, you just click go. So one thing to comment on is that when doing the initialization, for most of the times you could just like place it right on top of the table or on the ground, but there are some specific scenarios to avoid. So it is saying that, first of all, try to aim the LiDAR to some areas with features, meaning that it could be trees, it could be like buildings, but try not to aim this LiDAR head towards people, or like to try to or to surround this LiDAR scanner with objects like people or walls, basically. Also avoid initializing in featureless environment or like vastly open fields like this. One other important thing is because how the LiDAR lights interact with glasses, you probably would not want to initialize near glass curtains like this. And then one more thing to mention is that when initializing, try not to initialize the device with lots of moving objects near the device, because it will it will influence the LiDAR accuracy. Yep, so avoid crowds or avoid traffic, especially moving cars. During the initialization, this is what you'll see from the app. So it will start this countdown. So after you wait for about 15 seconds, you can start your actual scan. So meaning that you can lift up the device from the ground and proceed with scanning. But during this initialization stage, do not touch the device and make sure it is perfectly still. So starting from this initialization stage, you will be able to see, you'll be able to preview both LiDAR points over here and the video from the colored camera on the device. This is with this app is how you monitor the point cloud you collected during the scan. Yes, so this is how you initialize. So after initialization, it leads us into the actual scanning procedures. I will have to share my screen once again. Okay. So operation, after you have successfully initialized the device, try to follow with this video so that you are collecting so that you have like the best data quality. Yep, we'll cover some precautions and tips to help you achieve high quality data capture. We mentioned that we have two product lines. The collection method for the product lines are slightly different. For the L2 or like L2 Pro, so basically everything within the L product line, you can just hold the device normally, meaning that it's like held vertically compared to the ground, as showing over here. But if you're using the K series, you have to tilt the device slightly forward, let's say 15 to 20 degrees forward, so that it registers enough ground, so point clouds from the ground. During the scan, no matter which product you're using, avoid large swings like this. And do not place the device horizontally. You should try to keep the L series as vertical as possible, and for the K series, just make sure it's tilted about 20 degrees forward. Do not tilt it over, say, 30 to 40 degrees, and definitely do not place it horizontally. Yep, and during scanning, try walking at a normal pace. Do not jump like this. And when crossing, when encountering corners, do not turn too sharply, or do not like walk too quickly. Instead, pause at the turn for a while and then walk slowly around the corners. In narrow areas like this, or generally speaking in areas with lots of features, you should probably walk slowly than normal to ensure adequate scanning. What this is showing is that try avoid covering this LiDAR field of view by objects. meaning that you should not put this LiDAR, whether it's K series or L series, into very narrow areas like this. And then sometimes you might want to scan a room, like areas with multiple rooms or multi-story indoor buildings. When that's the case, you should pay close attention to how you enter the rooms. So when entering a room from the corridor, you should try to open all the doors in advance, as indicated over here. And then before you enter the room, try to pause underneath this door frame and stand sideways for a while, and wait until the point cloud shows up. The point clouds of the room shows up, and so they could be successfully jointed to the point cloud of the corridor, as showing over here. Correct. So when you see this, the point cloud of the room pops up and it's being successfully joined to the existing point clouds of the corridor, that's when you slowly walk into this room. If for some reason when you're scanning the door was not opened in advance, you should try to approach this door by blocking the LiDAR field of view from scanning the door, as indicated over here. So what he's doing is he's approaching this door backwards and blocking the LiDAR field of view from with his body from scanning the door like this. And then just slowly turn around, open the door, and stand sideways for a second or so, and then and walk into the room to resume scanning. In outdoor scans, such as areas with dense traffic, try aiming the LiDAR towards the site with static objects. Do not do this. Do not face the LiDAR scanner to the moving people or vehicles. So as these two videos mentioned, if you just follow along with the scanning procedure, you'll be able to capture great quality data, and will save you some trouble when you're doing the data processing later on. So I think what I'll do over right now is, so I can't go through all the specific tools from our software, because otherwise it will easily make this meeting 3 hours long. What I'll do is I'll just point you towards some more resources that you can turn to if you want to, say, play around with our software later on. I will share my screen and lead you back to this page, this support page. So here, for Lixo Studio, if you want to download it, just click this download link here. One thing I want to make sure that we're on the same page is that for both Lixo Studio and Lixo Cybercolor, so Lixo Studio for the point clouds, Cybercolor for the 3D Gaussian splats, they are very calculation intensive, meaning that they require your computer to have a very good CPU, GPU, and RAM memory. So before you actually download and start to test it out, we recommend you to go to this FAQ section, and then under computer requirements, you'll be able to find the recommended computer configuration to download and to run this software. So for example, for Lixo Studio, or the software for point clouds, you should have a computer that has the CPU better than this i7 11th generation. You should also have a GPU, the graphic card should be better than NVIDIA 3060. And try to have a memory that's at least 64 gigs. and similar stuff, you would like to try to check the computer requirements for Lixil Cyber Color. So over here, under LCC Studio, which is the software you use to generate the 3D Gaussian splats, under computer requirements, you would want to have a computer that meets all of these requirements. So I think that's most of the things I would like to share from me for now. We can probably spend some time going over the specific questions that get asked.
Perfect. We'll start at the very first one.
Yes, thanks.
Oh, wait. I'm sorry. I took my mic off. We'll start at the very first one, and we'll work our way down the list because there is a ton of really great questions. So thank you all for participating so much. Let's go ahead and start with this one from Mohammed at the very beginning. Pretty easy one to answer, I think. Max?
Yeah, you can actually do measurement from the mesh model. So from the Lixil Studio software, we do support generating mesh from the point cloud. But currently, we cannot allow you to view mesh with our software, so you will have to load in the mesh to some other software, such as like MeshLab. Yeah, but we do support generating mesh.
And then if he might be referring to the Gaussian splat as the mesh too, which you can take accurate measurements of the Gaussian splat as well.
That's true. Yes, you can take measurements on the Gaussian splats as well.
Another one from Mohammed.
Yes, of course. Firstly, we got the LCC viewer for the easy sharing. So you can send that LCC viewer to anybody you want to share so that they can view the data on their desktop very easily. And you can download the LCC viewer on our website, the download parts, the support part.
Perfect. All right. And then Chris Percivo is well known in the American. He asked about the range. He's going to kill me about his last name. I'm sorry, Chris.
Yeah. For the L series, we got two different kinds of type, or we got 120 meters and 300 meters, and both them is 905 mm. Yes.
Yeah, you can find this information by going to our official website, and then in products, if you just click into the product of your interest, and then over here, specs.
Yeah, the specifications.
Correct. Yes, you will be able to find. I think you're asking about the LiDAR heads over here. Yeah, there you go.
A safety class, and yes, it's 905.
Yeah. Okay, and then this gentleman is actually very active in the questions. I don't know if we'll go through all of them, but he definitely should reach out. You guys want to tackle this one?
The industry experience can be in private, or these clients can get with X-ray scanners. And let me see.
I think the biggest probably question in this is what pains can it solve, especially if we're probably already users of LiDAR, would be how I read that.
Yeah, I think for some power plants or the thermal use, these days we combine the scanners of the visual data with the LiDAR data, and we also got some of the products. They also have thermal data source. But in the power plants areas or industrial applications, people use the data for the plan, the construction plan, and as well as the assets management. As for Gaussian splitting, industrial applications, we in these days we try to carry out the whole solutions for the power plants, and that's one can be expected for industrial applications for these kind of scenarios.
I will say for me, especially one of the biggest pain points is when I'm scanning, especially interiors where there's a lot of different things I have to get around and scan. There's a lot of times where I'm like, oh my God, my RTC is going to be another 4-minute scan in this area. I don't know if I necessarily need to scan here. Whereas, with the SLAM scanner, I can just get it all real quick and then move on with my day. That's the biggest pain point for me as far as interiors and industrial scanning.
Mm-hmm. Yeah, that's the
And
point.
then let's see. Here's where you throw this one up.
Contact for quotes and others. Oh, you can find Mike.
Yeah. They are, reach out to Mindy or Faye's been in the comments if you're not in the U.S.
Mm-hmm.
And they will help you find a local dealer wherever you are. Because it appears we have quite a few worldwide customers here. So
Mm-hmm.
that is a good one. All right, here's a interesting one. I've already kind of answered, but I feel like we need to address even more.
Yeah, so in this stage, we only process the data from our scanners.
Yeah. So I feel like this is a two-part. Like you can merge the point clouds in like Register 360. I do it all the time with RTC data, but you cannot do G-Splats with it.
For Lexo Studios, we got map fusion functions there. So we try to combine or merge the data of the DJI AL2 with the Lexo scanners. But I'm not sure whether we can combine Novice VLX. Max, can you answer the question?
Will we compare it to Navis VLS? We'll probably have to answer this later on.
Mm-hmm.
Okay.
Yeah.
We will get rid of that then. Then let's see. Yeah, well, this one I actually just reposted because this is rather new. But I was kind of excited to see it happen. You guys want to chime in on this?
Yeah, we do offer. This is currently still under development. I'll say. So the merging between aerial solutions and handheld scan, but you can definitely mount this on a car. We've tested it out. I think it works for L series and for K series. Does it need to be on a stabilized gimbal's vibration absorption? Yeah, definitely recommend doing that. We have like a car mount that
Mm-hmm.
goes with the L series. So if you're interested in learning more about that, feel free to reach out to our salesperson.
Perfect. And then we'll get rid of that one. Here's another one that is a good one. Just mostly because I feel like this is a really strong suit for your app. And if you don't mind, I'll kind of cover it to start with. Inside the app, when you set it down on a ground control point, you get to label it right there in the app, and it makes the whole process just super easy. The UI inside their mobile app is probably one of the best I've played with. And I've played with quite a few. So
Thank you for that.
you guys have anything you want to add to the oh, I hit the wrong, sorry, I hit the wrong question.
Yeah.
There we go. That's what I meant to say. Sorry about that.
Best purpose. Yep.
You guys have anything you want to add to that?
Max, can you explain for the workflow of the control point markers?
Yeah, sure. So I think so you're saying control point markers. Those are like reflective targets that you're mentioning. I think those are mainly for marking up the control points. But if you know where the control points are, say like someone else from the survey team that's already marked it up for you, you don't have to like stick that sticker on the ground. You can just go ahead and use your the scanner, whether it's K series or L series, to place the base on top of that control point and then hit add control point on the Go app, Lixo Go app. It's pretty straightforward.
Oh, good catch. I assumed he meant GCPs. I didn't catch the markers. So
yeah, those are marker. Those markers are specifically for if you want to check the accuracy of your georeference data. You can just like place those markers to the ground or to the wall and then scan those area, like scan those markers during the data collection. And with our Lixo Studio software, there's a function called accuracy check, which will use those scanned markers. But yeah, if you're just interested in collecting control points, you don't have to place those reflective stickers on the ground.
All right, so let's move on to, and this is a rather random question because I believe there are demo products throughout the world where if you can find your local dealer, or when you find your local dealer, they should have
Yes.
demo equipment for you. Just kind of don't want to leave anybody out. There we go. Cooking mode. No. How about this one?
Combine.
So, go ahead.
Actually, I think here we got a viewer so that you can switch point clouds view to the Gaussian splats view, but actually that's not the real combination. So maybe you can explain the combination a little bit for the purposes or other ways people need to do that. Because as we propose, suppose that Gaussian splats got a better visual effect and point cloud got accurate effect. So we can use the Gaussian splats for visualization or viewing things based on the point clouds, but the point clouds may not be used for a better visualization presentation. So if you want to combine that, we don't use that combine. We just use the switch buttons to do the different kinds of purposes viewing in the LCC viewer.
Perfect. Is that, we feel like we've answered that one fully?
Mm-hmm.
I think so. Yeah. This one's, here's a kind of a softball one.
Is 3D Gaussian used for generating the mesh? Actually, we generate mesh in the process of the 3D Gaussian training. And the purpose for the mesh generation is the collision for more interactive 3D experience. Because if you want to navigate in that whole scenarios, Gaussian splats to get a more real experience, we got the mesh of the table and the words so that make you not get through the words. But the mesh is not for the traditional way use of that. And so in the process of the training, the two parts of the parts are separated. So you got Gaussians and the mesh. So the Gaussian is not used for mesh models. The Gaussians itself is an independent format for viewing. And the mesh, we overlay that in the viewer so that you will not get through the splats.
Perfect. And yes, this is going to be recorded here on LinkedIn. You can revisit it at any time. We'll also be releasing little parts of it here and there over the next couple of weeks, and it will be recorded and put on YouTube. This is a good one too. This is the last one in our list. And it's one of my favorite things about your guys' software is how easy it is to share the Gaussian splatting and stuff like that. It's just a URL you send to people.
Mm-hmm. Yes, Preview 3D is our partner. Yeah. So have any cloud viewing platform that allows us to view data alongside other TSL data, or are we best to use? Okay. So at this time, I think Preview 3D is a good choice.
Or you can just upload your 3D Gaussian splat data online and just share the link.
Mm-hmm.
Yeah,
we have a web viewer.
Mm-hmm, mm-hmm.
Which I believe earlier in one of the replies, I shared a link to one of the Gaussians I collected. So if anybody wants to check it out, it's real simple. You just put it in your web address and go. There is that. And then our last one here, which is pretty much what we just answered.
Yes.
Mm-hmm.
Yes. Yeah, exactly.
All right, and then I'm going to give us a few seconds because there is a little delay between here and LinkedIn.
Mm-hmm.
But any last minute questions? If not, feel free to reach out. I believe you guys are going to be at Geo Week as well, right?
Yes, the team will be there, and we will have a booth there, and we will bring over scanners and software there. Also, a very big surprise will be we will get a very immersive experience that there with
Okay. And are
our.
you guys going to any other shows in the U.S. this year?
So the things we can say is that we will go to NAB.
Okay.
Yeah, and we will bring over filming solutions together to go to the NAB.
Awesome. Yeah, I'm actually looking at going to that one myself. All right. Well, thank you guys, everybody, for coming. Make sure to watch out for the next one. And until next time, see you guys at Geo Week.
See you. Thank you very
All right,
much.
thank you. Thanks for having us again.
Listening.
Thanks to everyone's attention.
All right. So I just ended this.